All right, problem 28, the swimming problem. You have basically two heats. You have heat 2 and heat 5 there. And basically the question is there evidence that there's a difference in the mean times of those two heats? Okay, so what you would do is we're going to put those two heats. Heat 2 is an L1, heat 5 is an L2. So that's how we would set that up. When you do this out, these are the summary statistics you're going to get by using one bar stats of L1 and L2. So there's the mean time for heat 2, the mean time for heat 5, standard deviation for heat 2, standard deviation for heat 5, and then number of sample size for each heat. So our parameter here is mu equals mu sub 2 is the mean time in heat 2, and obviously mu of 5 equals the mean time in heat 5. Okay. The null hypothesis, mu 2 equals mu 5. Now all we're looking for here is the difference, right? So mu 2 does not equal heat 5. Okay. The assumptions and conditions. Okay. In this case, 8 is less than 10% for both heats. The two heats are independent. The heats were not randomly chosen, so we're going to assume that the heats are representative. And then the last thing we have to do is the normal condition, right? So let's go to calculator, stat plot, turn on plot 1, go to histogram, and we're going to do, okay, so that's for heat number 1. Let's see what my window is. I'm going to go from, it looks like around 256 to 270 by 2s. Okay, so that is roughly symmetric. Let's see if I can, let's see, maybe if I go by 3s. Yep. Let's see. Yeah, let's just stay with 2s there. So it looks like this heat 1 is roughly symmetric. There could be an outlier there. Let's check the box plot, see if there's an outlier. No, there is not an outlier. So it's roughly symmetric. It doesn't appear to be an outlier. We would copy that on our paper. And then we got to go to plot 2, and we're going to check the normal distribution. That's roughly symmetric with definitely no outliers. So both of them are roughly symmetric with no outliers. So those meet our normal conditions. Okay. Name the test. Okay. This is a 2-sample t-test. Our test statistics and parameters, everything is right there for you. That's what you get copied on your paper. Okay, so that's basically done. Obtain P. We're going to do 260.23 minus 250.78. Okay, over. We're going to do 3.03 squared over 8 plus 2.15 squared also over 8. Okay. And then that's going to be our T. I got to figure out how many degrees of freedom there are, and we'll figure that out in a second. So there's our equation. Okay, so let's go to stat test. We're going to go to 2SAMP t-test, and we're going to use data, right? So list 1 is L1, list 2 is L2. We're going to do not equal to. We're not going to pool, and we're going to draw. So this is what will wind up on our paper. So there's our T distribution. Okay, so T equals 7.2. Okay, so this would mean T equals negative 7.2, and T equals positive 7.2, and our big P is 0. Now let's figure out what our degrees of freedom is. So we're going to go back to the calculator, stat test, 2SAMP t-test, and we're just going to go to calculate and let the calculator, degrees of freedom is 12.62. Okay, that's right there, 12.62. So we got that down. So I'm just going to put this right here. So make the decision. We reject H of O at the 0.05 level. And our conclusion, there is evidence the mean times of heat 1 or heat 2 and heat 5 are different. It appears that heat 2 had a higher mean time. Yeah, so that's our conclusion.